Okay, so we were talking about what are the quantitative techniques, and if you look at the slide of yesterday, we can see that when we are talking about forecasting methods, uh, the different forms of forecast movement which we observe, and there were trend, random, cycle, and seasonal pattern. We will talk about this in detail. So there are three forecasting methods, and we right now we are mostly concerned about quantitative methods. So we'll be only talking about two different type of forecasting methods. These two methods are time series and regression methods. Okay, now time series methods are largely based on statistics, and they use historical demand data, which I think we already know, which you should have a past data available with you to predict the future demand. And in regression methods, we attempt to find out a relationship between uh, demand as an independent variable and any other factor as an independent variable. So we will be talking about these mainly in the chapter for forecasting. So let's talk about time series methods. So there are three different types of time series methods. We say that is moving average, the second one is exponential smoothing, and the third one is linear trend line. So let's see what is this first one, which is moving average. Moving average. Okay, now it is the most simplest form of forecasting method. Moving average is again of three types: naive forecast, the second one is simple moving average, and the third one is weighted moving average. Weighted moving average. So let's see these three individually. So first we talk about naive moving. Now I'll be shifting to different set of slides. So let's say we have this demand data available with us for last year, and orders per month are given. You can see that the orders per month are already given of the last year. And in naive approach, it is naive means that it is too simple and not that intelligent also. So for the first month, we don't consider anything. Like for January, we will not get a forecast, but for February we will get it like this. So previous months, for previous years last month forecast will be considered as the forecast for this month. So we say is a pre-period. So last year's first period will be second year's forecast. Okay, so this is the simplest one. So let's say this is year 2020. So forecast for 2021 would be somewhat like this. This is seldomly practiced. No one does that because you know that it's not going to be like this. Then simple moving average. Uh, Second one, in which this is the formula, we sum up the demands of when we are doing simple moving average, we have to define the number of periods of the moving average. Let's say 3 months moving average means that I will consider the demand of previous 3 months, take that average of the previous 3 months, and that will be the demand of the fourth month for the current period. So DI is the demand in the period, and is the number of periods in the moving average. So let's see what does it mean. So you can see over here that for the same data which was available last time, what we were talking about. So 5 month, 3 month moving average if we consider. So the question comes, why do we consider 3 month moving average? Why not 4 month? Yes, we can do that. But there are things which we will discuss, that what happens if we take 3 month moving average and what happens if we take 5 month moving average. We will compare that. So you can see over here moving averages. If it's a 3 month moving average, we will be only able to find out the moving average for the fourth month, or we'll be able to get the forecast from fourth month onwards, because for March, the previous 2 months, previous 3 months data we don't have. Okay, so it is suggested that if you want to find out forecast for March, then you need to have a forecast for December of the even previous year. Then only you will be able to December, January, February, March will be considered. So this is the moving average, and you can see here these three are the averages of these three numbers is given over here. 100 and sorry, not this one. So uh, you can see the moving averages for given for the last one. Their moving average is given over here. So if I have to find out the moving average for the November month, I will have to have August, September, and October's demand with me. Okay, now can you people find out what is the 5 month moving average for the November month? You have to give your answers in the chat box. You have to write 5 month moving average for the November month. Quickly do that. Let's see who gives the answer. 5 month moving average for the November month. Yeah, good. Okay. So I understand that you people know it now. So we can go ahead. So that's what you got. Good. Now let's compare 3 month and the 5 month moving average. What happens? So this chart over here, it indicates the smoothing effects. So the pink line is indicating 3 month moving average. You see here, the pink line over here, it is indicating 3 month moving average, while the blue line is indicating actual demand, and the purple line is indicating 5 month moving average. Now, can you tell me one thing, that which of the two curves is smoother? That means the smoother curves have an practical implication. I will talk about that. So which of the two curves is smoother, purple or the pink one? Yes, give your answer. Purple or pink one, which is smoother?
Purple.
Yeah, Jaswant, I could not hear what you said.
Purple.
Purple one is smoother. Okay. So when the purple one is smoother, does it mean that it is a good one? It is a good curve than the 3 month moving average? Which one would you prefer? Okay, let's say I'll ask your opinion, all of you. Which type of curve would you prefer and why? Why I will ask later, but you have to give your opinion first. What type of curve would you prefer? The third one or the 3 month moving average or 5 month moving average? So Carvey says purple she prefers. Other guys, it's like so Raghavendra, Rajkumar, Ritika, Shrija, Mood Kiran, Rajiv Ranjan. Which curve would you prefer, pink or purple, or don't know? You have to give the three options. One of the three options you have to write in the chat box. No idea, sir, how to decide. Good. Pink one, Raghavendra says. Varun Sani says, Ritika says, don't know. So only one person seemed to have a bit of opinion is Raghavendra. Raghavendra, why do you think that pink is what you like? Yes, Raghavendra? Because it has smoothing as well as near to actual values. See, now let's look at these two curves. One thing is that you are going to observe is that there will be a bit of a lag. Like this point actually corresponds to this point. Okay, so forecast for March is generally visible in April, right? Similarly, when it goes down, you can see over this point, April 1 is evident in May, and June is evident in July, something like this. Okay, so forecasts generally lag by one period. This is one first observation. The second is the shape of the pink curve is much more resembling to the blue one. Okay, while the purple one is far is pretty much not as much identical to the blue curve. Okay, but from practical point of view, who's going to use this curve? First question. Of course, the manufacturer is going to use this curve. Other people can also use it, but for manufacturer, the curve, these two curves have an implication. If you are a manufacturer, which curve would you like? Would you like the pink one or the purple one? If you are a manufacturer, if you are a manufacturer, which curve would you like? Because you have to consider one thing over is that you have to do production. Okay, and if you have to do production, would you prefer a demand which is of pink color, or would you prefer a demand which is of purple color? Think from manufacturer's point of view. What would he like? Okay, I'll give you the perspective. See, I'm doing production. My machines can produce uh, 50 units in a day, and I pay my workers accordingly. Uh, okay, so on one day I'm getting a demand of 10 units. Another day I'm getting a demand of 40 units. Another day I'm getting a demand of 35 units. So it is varying, right? And there's another scenario where I'm doing production, daily production of 25 to 30 units daily. So which one would you prefer? large variation in demand, catering to a demand which is varying a lot, or catering to a demand which is by and large average or a constant in certain range? Which one would you prefer? Varying demand or stable demand? Stable, of course. So, from manufacturer's point of view, manufacturer would like to have a stable demand. So, which of the two curves indicates more stability?
Purple one.
Purple one is indicating more stability. So, it's not like any curve is bad or good. Okay, it is like what is the practical implication of that? So for a manufacturer who would like to have a steady production capacity, he can build up inventories. He would be happy having inventories and no shortages. So stable demand, the kind of curve like 5 month moving average is good for him. While if there's a manufacturer who's having a lot of volatility in the demand, and mm, the keeping inventory is difficult for him or expensive, or the life cycle of the products is small, so that you can't afford to keep much inventory, for him the 3 month moving average is better. So here one thing we can conclude is that for the products which for if the demand for the products is stable, or you would like to have a forecast which will indicate a stable demand, you go for larger month moving averages. But if you like to follow the pattern of the demand exactly, and you have the capabilities of varying your production, then you can go for 3 month moving average. Okay, so we go ahead with our discussion. So this is called smoothing. Now, it is also evident that sometimes demand for product in certain months is more important than the demand for the same products in other months. For example, ice cream. So demand for ice cream is more important in summer months. Okay, um, or you can say consumer consumer goods like television, fridge, and all these things. The demand for these products is more important during the festive seasons as compared to that during the off seasons. Similarly goes with the automobile. So for certain type of products, the time of the year is also important. So hence we can go for weighted moving average, where it adjusts moving average method to more closely reflect data fluctuations. Okay, so we can give weightages to different periods, right? Like clothes. If you are doing for apparel, so apparel demand is pretty high and very important. You don't have any stockouts during Diwali, Christmas, and festive seasons where people purchase new clothes. So you would prefer to have more weightage to these months as compared to the other months like May, June, something like those, or when the exams are there, March. Okay, so let's say weighted moving average. We give 3 months are there, and we give weightage to October month more as compared to August and September, for the simple reason that in October it's a festive season. So we give more weightage to it, and the data is also given to you. So if you'd like to find out the November's forecast, so I will simply find out the weighted moving average, that is, you can see over here. 50 is zero point 0.5 and multiplied with 90. So this particular demand got 50% of the weightage as compared to the demand of the other months. So the November forecast would be somewhat like this. Okay, so it could be sequential, that, if you are going through, or at times you may want to give more weightage to the recent month or the past month, because uh, there are less chances that there's going to be an abrupt dip in the demand in the month of November. So October probably should be getting. So you can see over here, as the time passes, August, then September, and then October. So the weightage is increasing as the time is passing. Then you have exponential smoothing, which is considered to be most common form of forecasting method in forecasting. Uh, Weighted moving average and moving averages are also not that much used, but exponential smoothing is considered to be the most uh, superior among all these, because it follows the recent data more. It gives more weightage to the recent data on its own by the virtue of exponential. You know the curve. The exponential curve is somewhat like this, either this way or negative one like this. So it gives lesser importance to, if let's say you are trying to forecast for this period, so it will give more weightage to this data as compared to the data which is present earlier. So it reacts more to the recent changes in the demand. So exponential smoothing is considered to be a better option than the others. Okay, so let's see how do we do this. So I'll just make, so let's say ft plus 1 is the forecast for the current month, or the forecast for the current period what we want, and alpha into dt is the actual demand of the previous period which was available with us from the past data, and 1 minus alpha ft is the forecast for the previous period. So let's say, how do we do that? We got January, February, and March. Okay, and we have last year's data, that is 2020 data with us. That is, let's say this is 15, this is 18, and this is 20, and 2021 we want to find out. Okay, so the forecast for the previous period is available with us, and we want to find out for the March, for the April now. If you want to find out for April, so here we will say it is F4. Okay, and F3 will be this data. Let's say the forecast for the previous month was, I'm just writing that it was 19. So your F3 will be 19. So F3 is FT, and for the one for which we want to find out is FT plus 1, and DT corresponds to 20. So this is your DT. Okay, or you can say D3. Okay, so that's how we read these notations. And alpha is called a smoothing constant. Smoothing has the same meaning which we have already talked about earlier, and it is again decided by the decision maker. Just like you want to go for 3-month moving average or the 5-month moving average, you have to decide. Similarly, alpha is also decided by the decision maker only.
So the value of alpha would be less than 1.
It will be between 0 and 1. The
But
value of,
in
yeah.
that case, like we said, that the weight of the most recent data would be the stronger. So then
Yeah.
but then in that case, alpha would be like, alpha can be larger for dt. Like, so 1 minus alpha would be less for ft, whereas ft is the more recent data.
No, what happens if you give weighted like 0.5, and if you give it 0.6? So that depends. You want to give more weightage to the recent forecast, or you want to give more weightage to the actual demand? Hmm? Because at zero point 0.5, both will be given equal weightage to the actual demand or the forecast. Okay. And then when you exceed alpha, uh, when alpha is greater than zero point 0.5, then you give more weightage to the actual demand. And if alpha is lesser than zero point 0.5, you give more weightage to the forecast. Am I clear?
Yes, sir.
Yeah. Okay. So we go ahead. So let's say what I meant is this one. So alpha is 0.2, we can see. So if alpha is 0, then what does that mean? If alpha is 0, you're not giving forecast does not reflect recent data. That is it will just be equal to the previous month's forecast. Okay. If alpha is 1, then forecast is based only on the recent data. So you just have to find out a trade-off between the two. We'll take a numerical on this. So let's say this is a problem which we are talking about. So you got demand data for 12 months already with you. And how do I find out F2? That is forecast for second period. How do I find out that one? So this is the demand data which is already available. This is all the demand data. Okay, now you see some specific observations will be there regarding when you start with the forecasting. So F2, let's say I want to find out for period 2. Why I can't have for F1? Can anyone tell me?
So we'll need like ft minus 1 for that. So
Yeah, exactly. So that is not defined or not available. So that's why we assume that F1 is same as the demand. You can see here 37, and here also we have considered 37. And we take alpha is 0.3, and the demand is anyway 37. So forecast generally for the period 2 comes out as same as that is period 1. Mostly that happens in the simple exponential smoothing. Okay. Then we find out F3, that is for the month of March. We want to find out the forecast. So the demand D2, that is the previous month's demand, that is 40, and forecast for the previous month, which is 37, which we substituted over here. We get a different demand forecast now. Similarly, we can do it. Now, can you tell me the demand forecast for the month of May? Quickly do the calculation and tell me the demand for that is F5. Give me the value of F5. All of you do this. Give me the value of F5 quickly. Anyway, I have now displayed 39 point for the month of May. What you're saying is 39.652. I'll have to check that. Anyone else? Okay, for April, how much is it? Karvi, what is for April? What's the demand for April?
37.36.
37.36.
63. I'm sorry, 37.63.
Anyone else who's getting the same values? Or you can give your own value if you're getting something else. I want answers from the other people as well. 39.84.
Sir, actually, I like switched the 6 and 3. That is why the answer
Oh,
before.
okay, okay. So other guys, please answer. I know you all of you can do calculation. Find out a paper, newspaper, do whatever you want to do. Do the calculation. Nobody is able to do that. $37.63. Rajkumar Parikh for April is saying 37.63. And for May, $38.83. Actually, Ritika, that you are correct for April. You are getting the correct value. Can you post your calculation in the group?
Yes, sir.
F5 is 38.28. So post your calculation in the group so that everyone can see it. Yeah, if all of you can see that calculation. If you have any doubt, you can ask me. Karvi, you check your calculation. You agree with this or not? So this is the answer. You can check it over here. Okay, so I go ahead.
Sir,
Yeah.
for the fourth calculation, we take demand of like for April, we take demand of March.
Yeah.
Um,
37.
so like we can take it for April only, right? Because we have the earlier demand.
Just a second. So F4, you can see that D3 you have to take previous month's demand. That's how the formula works, right?
Yes, so that's what I'm asking. Like, since we
Yeah.
have the demand for April already, why are we
Yeah.
taking the previous month's demand?
No, that's how the formula works. That's how the exponential forecasting works. The formula, if you recollect it, uh, that's how it is. Ft plus 1 means April, and dt means the demand of March.
Okay, sir.
See, next period and the present period. That's what it means. So next period means April, and the present period is March. In March only you will be forecasting for April, right?
Yes, sir, but like I was saying,
And,
like if we take
no,
demand of April only, then we'll get a more closer value, right?
see, if you know actual demand, why would you forecast? Are you getting it? If you know actual demand, why would you forecast? It's like you are in April, you are in March, and you are forecasting for April. Getting it?
Yes, sir.
Yeah. So if we take alpha as zero point 0.5, how would that change? So similar kind of changes you would observe. As you increase alpha, uh, your demand starts resembling more to the actual demand. Okay, you can see that purple one is more wavy as compared to pink one. Pink one is much smoother. Getting it? So that's how, again, it's we wouldn't say that alpha equal to zero point 0.5 is good and alpha equal to zero point 0.3 is bad, because it depends on the decision maker. How would he like his forecast to be, and which suits his production system. Okay, So that's how it is. Now, this was the simplest form of exponential smoothing. We can do several other changes, adjustments also in the exponential smoothing. It's like adjusted exponential smoothing. We say, why would I do adjustment? Because there is a possibility of trend in the forecast. So if I have to incorporate trend also, that my forecast should resemble the trend, or it should capture the increasing demand also. So I would be doing adjusted exponential smoothing. So I'll just show you adjusted exponential smoothing formula. So adjusted exponential smoothing, AF FT. So there are two things which are happening over here. This is the main formula, like the previous one. And you see here, in the previous one, it was ft plus 1 alpha dt 1 minus alpha ft, right? But in this one, what we have to do is, first we have to find out ft plus trend factor, that is t plus 1. And ft plus 1 is just like we find out for the exponential smoothing for alpha, which is already given to you. So it's a bit more complicated than the previous one, but you can try to understand it in a different way, that you already have a forecast using simple exponential smoothing. Now you want to incorporate trend factor in it. Okay. So this is the trend factor, and T, we call it as an exponentially smooth trend factor. And how do we find out trend factor? Is beta value, which is also called the smoothing constant for trend. So ft plus 1 minus ft is a simple calculation which we already have from the previous data and the previous calculations, and t is the trend factor for the current period. Okay, and t plus 1 is the trend factor for the next period. Okay, so now let's try to do the same problem for the same data. Now we have trend correction factor also. So first what do we do is we find out t3. And how do we find out t3 is, so now again the question comes, why I am not finding out t2 first. So let's see that if I try to find out t2, what it would be. If I'm trying to find out t2, it will be beta f2 minus f1 plus 1 minus beta t2 t1, right? Now in order to get this value of t1, it will not be possible to get t1, because then it will be t0, which is actually not defined. So I can't get this term. Again, f2 and f1 are actually same in the simple exponential smoothing, as we have seen that f2 and f1 were same. See, f1 we just taken the same as the demand. So as we have already seen that it is equal to the demand, so that means f2 and f1 they cancel out. So then in that case I would be also getting 0 over here. So t2 is actually not defined. So that's why we start with t3. Okay, don't get confused over here. You can always work out with pencil and then understand it. So that's why we are starting with t3 over here. Now f3 and f2, where do I get these values from? So you can see uh, f3 and f2, 38.5 and 37. We go back and check. 38.5 and 37. These are the two values which we have taken from, considering that alpha is given as 0.5. We have taken alpha as 0.5, and then we have calculated these two values, and T2 is taken here as 0 for the simple reason which I have already told you. So T2 is 0, T1 is not defined. So T2 is 0. And then we calculate the trend corrected factor, that is 0.5. After doing that, f3 value. So f3 value is anyway 38.5, as we have seen from simple exponential smoothing. and T3 value is 0.45. So that's how we get is 38.95 as the adjusted forecast, trend corrected adjusted exponential smoothing forecast. Okay, and then we can find out T13 also. So if I have to calculate T13, I have to calculate all the previous ones. Okay. Okay. Now what you do is you tell me the value of AF4, AF4, AF4. What will be the value of AF4? Calculate the value of AF4. That is of April. Yes, guys. How many of you are doing calculations? Please raise hand. Good. Do that.
Sir, here we have to consider the alpha, the previous one only.
0.5. Yeah. So you can take these values I'm showing you. You can take these values.